Continuing with section 2.2 of the differential equations. So we are now looking at example 3. So it's solve the differential equation. Now remember here it doesn't say what method we have to use, but remember this section is about separable equations, differential equations. So we will use that method, and that's the only method you have learned at this time. Okay, so how do we tackle this problem? Now we have it like this. We cannot do the x, factor out the x, because one is 1 over x here in the first term, and then we have x in the second term. So how can we find out that it is separable, and how can we solve it? Well, if you move, there are two terms in this equation, one with dx and the other with dt. So we can move one of them. So I will move this one to the other side, and I will also write x to the negative 1 as 1 over x. So I get 1 over x dx equals negative x e to the cosine t times sine t dt. So now you can see it is separable, because now I can move this x to the other side. So divide by x on both sides. So I get 1 over x square dx is equal to negative integral e to the cosine t times sine t dt. So we are integrating both sides now. So left hand side, okay, maybe we should have left it like this. So it will be like that. And the right hand side, you can say u substitution. So u is equal to cosine t. The derivative is du is equal to minus sine t dt. Okay. So this is equal to integral. And now I will make the substitution on the right hand side. So we have e to the u times du. Right? Because this negative sign, the sine of t and the dt, they make up the du. So now on the left hand side, I get x to the minus 1 over minus 1 equals e to the u plus c. So that we get 1 over x, negative 1 over x equals e to the cosine t plus c. Okay, so now we have to get it in terms of x. So what do I do? First thing I do is multiply both sides by negative sign. So I get 1 over x equals negative e to the cosine of t plus c. So now I flip, because in the denominator here is 1. So I will flip both sides. So x over 1 over x becomes x over 1, or just x, equals negative 1 over e to the cosine t plus c. So that is our answer. That is the solution. So remember, c is at the bottom. Now if this were an initial value problem, so if you are given a condition, initial condition, then at this moment or at this time, you will plug those in and get c, the value for c. Let's look at the next example. This is solve the IVP. So now we have to solve the initial value problem. Okay. So we can see it's a separable. So we can move the 2 on that side and dx. So I'm going to write this equation as dy equals two times square root of y plus 1 cosine of x dx. Now I will move this thing over here on the left side. So dy over square root of y plus 1 equals 2 cosine of x dx. Integrate. So the left hand side, we can take u equal to y plus 1. So du will be equal to dy. Simple. So your integral becomes integral du over square root of u is equal to 2 times sine x plus c. The left hand side gives me, remember this will be u to the negative 1/2 and du. So when you integrate, this will give you 2 times u to the 1/2 is equal to 2 sine x plus c. Plug back the u value and we will divide by 2. So you get u raised to the power, we will replace the u by its value, which was cosine of, which was y plus 1. So we had y plus 1 raised to 1/2 is equal to sine of x plus c over 2 because we divided by 2. Now if you want, we can leave it as c over 2, or we can call this a c1, and now I will call this a c. So c will be equal to c1 over 2, or we can just leave it as c1 because it is the c1 is a constant, divided by 2 it's still a constant. So now we can write it as y. So the y plus 1 will be equal to maybe we can first find the c here. Yeah, I think that will be better. So let's say we don't call it c1 because eventually we have to evaluate it. So now we plug in the value. So y of pi is equal to 0, which implies, so when x is equal to pi, y is equal to 0. So in the left hand side I get 0 plus 1, or 1 raised to the power 1/2, which is just 1. So 1 is equal to sine of pi plus c over 2. Now sine of pi is 0. So I get 1 is equal to c over 2, or c is equal to 2. So that my equation is now looking like 2 times y plus 1 raised to 1/2 is equal to 2. Actually, yeah, we had removed this 2. Sine of x plus 2 over 2, which is 1, because c came out to be 2. So I have y plus 1 to the 1/2 equals sine x plus 2. So that y plus 1 will be equal to, so I have to square both sides, so sine of x plus 2 whole squared. So y will be equal to sine of x plus 2 whole squared minus 1. So this is how we do this separable equation. Okay, in the next section 2.3, we will learn another method.